That's your stage in the middle. Yeah. Parfait.
Hey, thank you. Hi, everyone. Thank you so much for joining us today. We're going to be spending together the next 30 minutes. So just a quick introduction. My name is Marinela Profi. I work at SAS for almost 10 years now. I am a statistician. I lead the product strategy team for our Agentic AI solution. It was AI before. It has changed over the past 2 years on Agentic AI. That's all we talk about these days. And I'm based in the US, but I travel a lot. So I say that I'm based worldwide. So, Jean-Laurent.
And I'm Jean-Laurent, JLP. I'm the CTO for Intel EMEA. I've been with Intel 32 years. And my background is in high-performance computing and cryptography. I have a PhD actually in breaking RSA codes, which is interesting at the moment. Everybody talks about security.
Yes, very, very helpful. Okay. So I wanted to get started with something that I think everybody is hearing a lot these days, right? Which is AI is moving fast. Those who will not, invest it right now, they will be left out. If you hesitate, you're going to lose the game. Your competitors are going to be faster than you, and you're going to, the competitive window is going to close. So that is something that I personally have heard, and I hear my customers hearing it a lot over the past year or so, more and more. And it is a valid argument, right? It's technically not entirely wrong because the technology is here, the rush, the urgency is here, but it's also a very incomplete story, right? So over the past 2 years, as I said, my job has entirely shifted. So I'm a statistician. I'm specifically specialized in forecasting models, so provisions for the future. And over the past 2 years, my jobs have entirely shifted into Agentic AI. These are some of the real-world use cases that we have been working on over the past 2 years on Agentic AI and generative AI. We're going to see some use cases over the course of the presentation in more details. But one thing that I think that we have learned over the past 2 years in working with real-world organizations is that the organizations that are moving fastest with AI are not necessarily the ones that are building the most durable advantage. What I mean by that is that speed is not the variable that will necessarily decide who will win or who will lose in the Agentic AI era. Structural readiness is. So what do I mean with structural readiness? And that is what we are going to find out today over the next 25 or so minutes, right? So what we have seen over the past 2 years working together in collaboration with our customers, our partners like Intel, is that there are three main traps that organizations who are investing into Agentic AI are constantly falling. And these three traps feel very strategic. They feel very right in the beginning. But then as you continue to invest, they come out as traps. They come out as challenges, actually. So let's explore each of those three right now. The first one. The first trap is that every organization I'm speaking to over the past year and a half is obsessing over the model. What LLM should I use? What is the company with the best benchmark? Should I build my SLM? Should I invest in an LLM? What's the best LLM? That is a valid argument, but that is not what is going to make a difference, really. What is going to make a difference, actually, is starting with the data. Trusting the data first. I've heard many sessions today and yesterday and Wednesday, and this is an argument that it's coming more and more. I've heard this from other speakers, and I'm really happy to see that there is a growing and increasing focus on the importance of the data quality, right? And the reason for that is because we have moved with Agentic AI. What basically is happening is that we have moved from an AI that only informed to an AI that now can act. And that changes the entire paradigm because before the human was the control layer, and now that control layer can basically be gone. We don't have that anymore, right? Even though it should remain in the loop. So what happens is that a data quality problem in the Agentic AI era is not a reporting problem anymore. It becomes an operational risk. What I mean by that is that a data quality problem doesn't just create a wrong dashboard or the wrong reporting or a skewed dashboard, it actually triggers the wrong action, which can be a procurement decision, which can be sending the wrong communication to the wrong customer at the wrong moment. And a lot of that is actually being driven by the fact that there is still a lot of misconception today in the market what an AI agent even is. A lot of people still think that an AI agent is you get some data, you give it to an LLM, and you get some value. But the reality is much more different than that. If we try to plot, and this is probably not, this is still going to change over the next weeks or months, but if we try to plot the life cycle for an AI agent, it's completely different than what we think today, right? So it's not just the LLM. You have so many more components that are internal to the agent and external that influence. And specifically, in working with organizations over the past year and a half, we found out there are 4 main components that make an AI agent, right? It's a combination of large language models, that's one part, a combination of deterministic models, so what today is called now traditional machine learning. It has already become old for some reasons, even though it's still driving the biggest value and money worldwide, right? Traditional ML. You still have that as part of the agent. You have data, tools, access to data and external tools, and guardrails. I love to talk about guardrails when I talk about agents, because guardrails, I like to say, have become the sexiest thing again when we talk about agentic AI. And some people underestimate the importance of deterministic guardrails when they're building agents. But that is what is really going to make a big difference. I've collected here, and you can download, this is a free access tool PDF that you can just download it. What are the main deterministic guardrails that you need to think about when you start building agents, right? Like, what are the questions to think and ask yourself first before you even start writing the first line of code, or you ask AI to write it for you, because these days nobody likes coding and learning how to code anymore. So this is the first, a tool. Okay, so now Jean-Laurent is going to walk us through another problem that is related to data.
So data is the oil. That's your IP. It has value. And as Marinela said, it is super important. So you have to first trust the data. The data will help you retain some sovereignty, but the data needs to be secure. Until now, sovereignty was more about making sure that you have scalable and high performance and cost-controlled solutions. Now, AI has become more critical through the data, which has become more critical for some industries like defense, health and life science, finance. So all of this and beyond require that they understand and own the data and understand how the data is processed, where and who has access to it. Given all of the geopolitical situation that we are living in, having sovereign solution, which means some level of autonomy, is very important for the enterprises as well as for the public sector. Cyber criminality is super high, and that's why you have to really protect all of your data, your VMs, and everything. Because it is creating an economic risk, and as Marinela said, it's at the operation level that you might run into some serious issues if you don't control what's happening and where it is happening. Therefore, sovereignty and security have become a board-level topic that needs to be discussed there to control the risk that is being created through these new paradigms. And as we are in the EU, and that's valid for nearly every region, there's a level of regulations that is being imposed onto where the data resides, where it is moved to, where it is computed, how it is handled. And the EU is at the same time having more sovereignty for the enterprises as well as for the countries and the government. And all of this means more autonomy. That's why, since data is so critical, we have to make sure that at the moment we know that the data is secured in most places, but we need to increase the level of security for the data so that it is not compromised or hacked. It is very clear that until now, your data, whatever it is, was secured at rest because you encrypt it. By the way, if you don't encrypt it, it's time to encrypt it. And if you encrypt it, it's time now to use encryption mechanisms that are post-quantum computing capable. And we already have post-quantum compute encryption mechanisms in all of our solutions at Intel, at SAS, so that the data that you value today that might be used in 10 years, when quantum computing is capable of breaking the encryption, you have it secured by having post-quantum compute encryption now. So data is safe at rest. It is safe in transit because you encrypt it with TLS or something like that. Guess what? When it gets onto the CPU, the data gets into the memory, and in the memory, the computer has to decrypt it to be able to compute it. So there is a risk there that someone does a memory dump and can read the data. And trust me, we have shown some real-life examples where we have been able, through a user or an operator who has root access, to get all of the credit card codes out of memory. So you have to encrypt the data while they are being processed. But then that's an oxymoron because you have to decrypt it. We have a solution. SAS and Intel have worked on a technology which is called TDX, and TDX is Trusted Domain Extensions, which is hidden from you. You don't have to know about it, you just have to enable it. And SAS solutions are enabling it, where actually the whole application, let's say the VM, is completely encrypted, and in order to execute, it has to request attestation, which means that an operator cannot compromise it. It is secured. The data is decrypted inside the enclave that is attested in the memory, and then it can run, but no hyperscalers, no other software, no other resident on the same machine, no applications, no operator, even if they have root access, can see it. They can dump the memory, but it is encrypted for them. They don't have the attestation. This is the huge thing that makes the difference. Data needs to be encrypted all the time, and SAS plus Intel TDX do it well.
Absolutely. So Jean-Laurent, and these are just some examples, right? Why that trap, the first trap, obsessing over the LLM is not the right place to start, right? Data quality problem, data security problem. So these are just some examples. Now, moving to the second trap. We talked about it a little bit before, mistaking speed for strategy. What I'm hearing a lot of executives or senior leadership focusing on is let the team experiment, put an agent in every workflow that you have, let the creativity run free in the company, right? And that is an approach, but sometimes people are mistaking that speed for strategy, right? And then what they're not thinking about is what it actually really is going to matter since day zero, and they're going to hit a wall pretty soon, which is governance. I'm hearing governance becoming more and more important, and I'm really happy about that. I was in the US a few weeks ago, in Japan in the beginning of the year, and governance is it's becoming more and more important. So I'm happy to see that. But I'm still hearing a lot of belief that governance is what slows down innovation. And that is not true. Governance is actually the only thing that is going to make responsible AI deployed possible. Otherwise, it's not going to be possible. And we're seeing that more and more. And the reason why governance is so important is because, especially for agentic AI, a single ungoverned agent, and we have had scenarios where this has happened, can simultaneously trigger all these policies, all these regulations. right? And you don't even notice that. So if you don't have in place a tool or a mechanism or something that tells you how that agent is behaving or is compliant, right? We start entering the territory of compliance towards the regulations, which, by the way, are changing weekly, and we don't know how that is going to evolve. You are going to hit a wall pretty soon. And your innovation, whatever the best pilot you've built, is not going to be able to make it into production. Now, I mentioned that over the past year and a half or so, I've worked with agents. I've showed you some examples before. We're going to see more examples towards the presentation. But when starting to build a framework for AI governance, these are the 8 variables that are working so far. Governance is shaping. These variables might be different in a year. Next year at VivaTech, we might be showing and talking about governance in a different way. But these are the 8 variables that we are seeing so far being really important when we talk about governance. The top 4 are the ones that are really important before you deploy the agent or before you deploy the AI system that connects to LLMs, right? Even if it's not agentic in nature. The other 4 at the bottom are the ones that you have to worry about and consider after you deploy. So this is a framework that we're seeing really working for agentic AI governance. This is a use case that I brought. We have a booth right here, the SAS and Intel booth. If you want to see more use cases, more demos, we're there. But this is a use case that I brought. This is available online. You can look at it. We work with National Bank of Greece, where you're seeing at right there, that is the agentic AI workflows that was built. And the reason why I brought this case is because it was entirely in Greek language. Processing documents in Greek language, it's another level. And making an agent understand Greek and being able to make decisions on that, it's a whole other level while caring about governance, while caring about data encryption, while caring about data security and all the things that we just talked about. So this is an example that was built with SAS Via, which is our data AI platform. And it was about document and request customer categorizations, a very simple use case, but is where we are seeing the majority of the value being driven by AI agents. The simplest use cases, not the most complex ones. The third trap, Jean-Laurent, this is your turn.
Yeah, absolutely. So, as Marinela said, everybody wants to get into AI. They want to get AI into operations. And at the moment, the buzzword is agentic AI. Do I need an agent for everything? Marinela already answered no. And the answer is absolutely no. You need to really make sure that you focus on the problems that would require an AI agent. What's interesting, and you've probably seen it in the press, we have seen some companies that have decided to let their employees use agentic AI for everything and the rest. And some have actually deployed or designed agents that are taking more time than if they have done the job themselves. One. Second, everybody believes that tokens are free. At some point in time, they were. In some cases, they still are. But there was a company that received an invoice of $500 million for tokens that were, let's say, a little bit too much use. So you have to really think about what you need an agent for. And that's one of the basic things. You need to work on the infrastructure that you will be using and implementing to develop and operate the AI agents. It is important to think about which applications you will be using, in other words, which AI agents, and design the infrastructure for it. First, you don't need an AI agent for everything, but in a lot of cases, AI agents can run on your existing infrastructure, may not need a GPU, and a lot can be done directly on the CPU. So you have to consider that we are moving from a model-centric solution to a system-level optimized solution. And as I said, depending on the AI agents, on the workloads, they don't necessarily need a lot of GPUs. If in the past for training, the recommendation was about 1 CPU for 8 GPUs, it's been moved to now 1 CPU for 1 GPU. And when we get to real agentic AI and to physical AI, the latest projections show that it will be between 8 and 10 CPUs for one GPU or for one accelerator. So you have to think about the infrastructure, purchasing systems that will have, you buy a data center with plenty of racks that have 8 GPUs and 2 CPUs, you're going to have a marvelous bazooka to kill a mosquito, and then you'll have to pay the price for it. So the workloads need to be really taken into account. And that's why choosing the right CPUs, typically the Intel Xeon 6 or Xeon 6 Plus processors that are really good at orchestrating, at accessing data very efficiently, and at operating and executing AI applications because they have integrated AI accelerator in it, means that you can do RAG and SLM inference directly on the CPU without having to have a GPU on the side. So that's really important. And then, how do we get there in terms of my recommendations? Just because SAS and Intel work together and talk to you, talk with you, listen to you, and we look at your requirements, what you say and what you need. And we see that now there's a shift toward more compute needed in the data center or in your applications. The performance and efficiency are really critical, and the CPU is important for that. You have to have a cost-effective solution, otherwise you're going to not be competitive or potentially lower your TCO and potentially lose money. So that's why it is important to think today about what you will be doing tomorrow, because the infra that you're putting in place now needs to live for a few years potentially. So the collaboration between Intel and SAS gets there, and we've been working together for more than 20 years. So when we talk about decade-long collaboration, it's real. And we listen to what SAS is telling us based on their customers' feedback. We listen to our partners and customers. We design the hardware that we will be doing the basic things, and then we work with SAS so that the applications take advantage of the hardware that we design so that it is better for you, higher return on investment, lower TCO, high performance, all of this ready for the next generation of AI capabilities that are, of course, agentic AI now, physical AI tomorrow, and AGI the day after tomorrow.
Yes. And we have brought an example today of an application that we launched recently in May. It's called SAS Retrieval Agent Manager. I have a very quick 1-minute demo to show it to you in action in a few minutes with a real-world use case. But just to introduce it to you, SAS Retrieval Agent Manager, also known as SAS RAM, basically it's a very lightweight, flexible solution that allows you to upload documentation, whatever it's PDF, notes, policies, guidelines, whatever type of unstructured data that you may have in your organization, allows you to create collections out of it, and then allows you to basically create a governed knowledge layer that you can access that knowledge with the right context through a chat interface in an API way, or having an agent or an application access that knowledge to reply back to you. So you're seeing here on the left the workflow that allows you to basically upload documentation, evaluate what RAM does. It creates collections for you of different documentation, evaluates the retrieval knowledge, and then suggests for you the best, basically, next step to be able to create that governed knowledge. All we're building governance, we're building security and explainability as well. You can see on the right that the solution is very flexible from a deployment standpoint. If you want cloud, that's fine. If you want like more on-premise, if you care more about that data ownership, that's okay as well. So we run on all the deployment phases. And Intel played a huge role into this solution.
Yeah, absolutely, Marinela. So SAS are the brain behind the application.
The analytics, yes.
And we bring the ingredients. So the CPU, that's why here you can see that it's been optimized for the CPU on Intel. It's using some of our Intel building blocks that are also some pieces of software that are open source. typically the Onyx and the OpenVino solution that is bringing AI easily to you without having to be an expert, so that it gives high performance for the application as well as low latency.
Absolutely. So let's see it in action. I'm going to ask the production team to just run the demo now. So what I'm here in RAM is I want to reply a question that I received from a customer. I'm an employee from a benefit. So I'm going to ask the agent for that. And what the agent is going to be able to do, this is a very fast demo, guys. We only had 1 minute to run it. Is going to be able to access all the sources of data, both structured and unstructured, and it's going to tell me exactly what it takes from that information. Now, I can ask any type of question on my benefits and my policies that I have. But what I want to do is I can ask the agent things like, which citizen should I propose this benefit? And what the agent is going to do is access machine learning models behind the scenes and tell me 5 customers that I should reach out with this benefit. I can do something even more and ask, why did you suggest this specific customer? So give me the explanation behind that basically suggestion. Behind the scenes, there are explainability that it's built in within the machine learning models that, based on the retrieved information, the agent can access and tell you exactly which were the reasons why it suggested you a specific customer for that offer with respect to a different customer as well. I can ask what other offers I can suggest to this customer, and the agent is going to be able to retrieve the same information, trigger a decision model, and tell me, and then help me compile an email, essentially, to send to the customer. So it's really just more than just research layer. RAM is really about combining LLMs, retrieved knowledge with the right context, and deterministic models to allow you to have an agent that you can build within the solution itself that can basically trigger a decision model when it's needed, can trigger an LLM when it's needed, can trigger a simple copilot if you just need to write an email, but having that end-to-end agentic AI experience at your fingerprint. So a fingertip. So we do have a booth. I would love to show you the demo more and have RAM explore it for you in your use case. SAS and Intel is right here. So that is just a quick demo. I wish we had more time to spend on it. But Jean-Laurent, why don't you wrap us up?
Yeah, absolutely. So I'll be quick on this one. As I told you, you don't necessarily need a GPU or GPUs in addition to your CPU to run your application. You have to think about your infrastructure based on what you will want to achieve. And that's why with RAM and running on Intel, you will have good solutions from Intel and SAS. But what's really under the hood is something that we can tell you about. Please don't hesitate to come to the booth. We will tell you what we have done together, how it can apply to you, how to not fall in the traps that Marinela and I have been showing you, and we have given you some hints about where we can help you avoid this. CPU is where you need to start with your applications because you obviously have CPUs in your servers, in your data centers or in the cloud, and then you have to think, do I need anything on top of this? With this, thank you very much.
Thank you so much. If you have any questions, now it's time to ask us.
And the booth is just here on this side, so don't hesitate to come and visit us.
It's a very short walk.
Booth A47, yes.
Thank you so much.
Marinela, Jean-Laurent, congratulations. What a super talk.